I think we've just had two excellent presentations from ABB and Honeywell, and what that's allowed us to do is to really kind of cover some of the bases with respect to connected buildings. And in this session, what we're going to do is to drill down into a little bit more detail and to look at probably the biggest opportunity in the world at the moment for connected buildings, which is small buildings with no energy management systems installed currently. Looking at some of the market dynamics and data, there's three things really come out. Number one is that the IoT continues to grow exponentially. Number two is that there is a vast number of small buildings out there, about 26 million buildings in Europe alone. The majority of those will be small buildings, small companies, or big companies with lots of small buildings. And to make the opportunity even more attractive, most of these buildings are very poor in terms of their energy management. In fact, nearly half the energy is actually used outside of business hours. So it's a really tremendous opportunity to partner, innovate and win business. I think in some of the previous presentations we got a clear message that sophisticated connected systems have been in use in large buildings. I spent my entire career working in these types of buildings. In fact, I was scratching my head the other day. I was thinking back, and I used to design electromechanical control systems by hand. And when you made a mistake, you had to scrape off the ink with a razor blade, and then of course all the ink would just go all over the place. And when we think that the journey we've been on and where we've come today. Connected buildings, big buildings, airports, hospitals, it's more of an evolution. There was always going to be something in there. But today, there are technologies, communications technologies and devices that can be applied to small buildings as well. And they can be applied in an affordable way to meet ROI models and other business models. One of the main sort of drivers is the advances in wireless technology. So there's two particular protocols, Zigbee, Z-Wave, but there are others. And they allow intelligent IoT devices to be installed in buildings that don't require to be wired. They don't require electrical power. They'll run on light, and not even natural light, just light from these lights here, or vibration, or they may have a battery, like a 10-year battery. Mesh networking is very good for these devices. The more devices, the stronger the mesh. And another factor is life cycle cost. Most buildings are reconfigured during their life cycle, so walls are moved, a shop gets laid out differently, and with wireless devices, the device can simply be taken off the wall and put on the other wall. Obviously with a wired device, it's going to be much more expensive and messy to make those changes. Once you deploy an IoT-based solution in a small building, it also opens up opportunities for interoperation. So instead of having single function devices that only do one thing, you can start to get more value out of your assets. So one example would be linking the proximity sensors that are used for the security systems to the air conditioning systems, to the lighting systems. So it's very simple. So some offices are already like this. When you walk out of the room, the lights are going to switch off automatically. The air conditioning is going to widen its band of control, so it'll get a bit warmer if it's a hot day, it'll get a little bit cooler, and then when you walk back in, the band of control tightens up again. Another example is things like window contacts. So the window contacts are there for the intruder system, but they can also be used to switch off the air conditioning if people open the windows. So very, very simple. Occupants, workers in the building, again, things like cashless vending. So you have an access card, you use it to get in and out of the building, but why not use it to get food and drinks? You could be used in a small school to take out library books and other applications from the same device. Another good thing is to have some sort of fixed display in the building. We usually put them into kitchens, staff rooms. And what this does is it starts to promote energy awareness and awareness of how the building is working and what people can do. So when they switch the kettle on, they suddenly realise that it's using a lot of energy or it's costing a lot of money. Maybe the next time you can maybe half fill it instead of fully filling it. And we do get a lot of feedback from customers that awareness alone can actually save energy and save cost. Now, a little bit technical, but there are traditional approaches to small buildings that are already taking place, which is basically taking a device which was designed for a big building and using it with some wireless devices. Now that device will need to go inside a panel with all the, I use a colloquial English term, gubbins, go along with that. But really to innovate, we need to work together to come up with something which is more streamlined and more cost effective. So, you know, we need to lose the panel, we need to lose the circuit breakers, lose transformers, lose receivers, routers, lose the DDC controller, and then innovate to produce a product with simply screws on the wall and will manage an IoT system in your building to make it safer, to make it more efficient, and to make the people in the building more productive. Now, there are different types of small buildings. Some small buildings, like shops, I have to be dragged into, but this type of small building is my favourite type, and I have to be dragged out of it quite often. So let's look at a bar restaurant, just as an example. So typically, bars and restaurants, they are not very efficient, and it's a good opportunity for an owner to make more profit. Significant savings can be achieved, and some of the measures that need to be taken are very, very simple. You know, you walk past any bar in the evening and you can see the gaming machine or whatever it is still switched on. My own local pub, it infuriates me. There's an overdoor heater, and in the summer it's practically on all year, burning energy unnecessarily. So simple measures can be taken. The way that energy is used in one of these types of buildings breaks down into heating, lighting. Quite a lot of energy is used actually in the cellar to keep the products cool. So as we discussed, raising awareness itself using real-time energy display can reduce consumption by up to 30%. Quite often the cellars are overcooled, and just by changing it by 1 degree, you could save 10%. We are quite familiar with lighting, and that's a good industry that's going on, LED lighting refits. And then controlled systems, so actually controlling your heating system properly. Number of times I've been in bars, and it's a mild day outside, maybe 15 degrees, and you put your hand on the radiator and it's bouncing, and it's so hot. Quite often heating and cooling systems are working simultaneously. So again, these are some simple measures. So one of the most obvious things to do is to switch things off when you don't need them. Night load reduction. Now, it can be that you could use just a display which shows you your energy consumption. You could go around and manually switch everything off, but at the end of a night, people are less likely to do that. And in some cases, it's not really their fault, because the switch might be way down on the floor somewhere, or that might be too high up to switch off. So the idea is to automate that through the use of wireless relays and smart plugs, which I think you'll probably be familiar with. So that's a nice simple application. Another application is what we call deadband control. So this is what often happens in buildings, where the air conditioning system is independently controlled and operating, and the heating system is completely independent as well. And so, simply by installing a couple of wireless relays, you can impose a deadband and stop the situation of simultaneous heating and cooling, and get some good savings and payback from that. We mentioned scheduling and zone control. So quite often these types of buildings, they will have like a function room or upstairs restaurant perhaps, which is only used at night. But in most cases, these spaces are fully conditioned. They'll be heated or air conditioned, maybe even the lights will be left on. So some simple zone controls adding in will help save more energy. Even things like the production of hot water to these areas as well, it can be zoned. So, accurate time scheduling too. And then when you add remote monitoring and analytics to that, so if you're actually providing also a service where you have specialists that are looking into the data, there'll be more opportunities for energy saving. One particular bar, we noticed that at night time, they're still using quite a lot of electricity, and and it's the car park lights. They're on a timer, and for most of the year, there'll be 4 or 5 hours where it's still light outside, but the car park lights are on. So just simply fitting a photo cell switches the lights on when they're needed. So a lot of the measures that we're taking are pretty straightforward. They don't require highly skilled engineers to implement them. So this is what it would look like. So you would have various technologies installed in the building. You would have your, if you like, the brains screwed on the wall, connected to the devices, monitoring your energy consumption, the smart plugs, switching devices off when they're not needed. And we mentioned drinks fridges as well, so that's another classic one. Nearly all bars anywhere in the world have these fridges on 24 hours. Now, strictly speaking, at 5 AM, the product does not need to be at the optimum temperature, but it does when you want to serve it to a customer. So again, it's just simple things like switching it off, bringing it on at maybe, I don't know, like 6 AM, allowing the product to be at the right temperature when it's served to the customer, but doing it in a more intelligent and more efficient way. What's really important is affordability. I didn't mention that before. So what we've developed is a scalable approach to this. So customers can invest a small amount of money in just the monitoring and behavioural change if they wish. Or they may have 100 buildings, and we could deploy monitoring in the 100 and then deploy controls in the worst performing 10 or 20. So there's a way to scale this, and you can go for it all at once, or build it up gradually and maintain the return on investment. Obviously, the more you spend, the more you're going to save. But I think to get in there, get something affordable, low cost, especially for a partnership with E.On, it gets us the customer. You know, we win that customer. And then we've got a relationship that we can add value to, and then the customer can see that they're getting a return on their investment, and then we could possibly add further services on top of that. Also, the display gives us a digital touch point. So we're having a digital relationship with that customer, and it can be a two-way relationship as well. There's nothing to stop internet feeds coming through, communicating with the customer, gamifying some of the energy saving functions, and it just opens up a whole landscape of possibilities for us to innovate and work together and get a better understanding of our customers' needs. So one very important aspect as well is that we don't want to end up with an asset which kind of just becomes out of date very quickly. We've seen some great presentations on the rise of technology and the pace of change. So it's important to future-proof as well, to put the communications capability into your product, to future-proof. Now, one of the, we've actually touched on this in some of the other presentations, there's a big growth in wearable technology. And future buildings, to make them more healthy and productive, will actually function to provide comfort as it's actually experienced, the human experience of comfort. So your actual skin temperature, your blood pressure, and the type of wearable tech that you can actually wear in the building. And what this will mean in future is that people will be in the building, and the building will start to adapt and function to meet the needs of the occupants. Classic example would be this room. If it's completely full, the occupants may be getting a bit hot, or the air quality might be deteriorating. There could be too much CO2 in the room, so the building could respond by bringing in more fresh air, altering the various dampers in the ventilation system and bringing in more fresh air to make people feel more comfortable and hopefully not fall asleep during the presentation. I haven't noticed anyone doing that, but it has happened to me before. But never mind. So that's really the vision for the future. But I think it's very important that we work together, we innovate, and we make a start and win those customers to start with. So, in summary, we really think that there is this huge opportunity that what we call nano BEMS, the very, very smallest type of system. That is the way forward for these small buildings, and there is going to be future developments, so we just need to get the right platform where we can continually upgrade the product to get those future developments in there as well. And I really believe that together we have an amazing opportunity to work together and to win more customers for E.On. Thanks very much. Take some time.